something that we have been sorely needing in Bitcoin SV for forever almost is high-level languages, so that people can build functionality in script with ease. I first met Xiaohui from sCrypt quite a few months before sCrypt kind of made its first appearance, and in fact our very first conversation was about the desperate need for high-level language compilers. I had no idea that he had gone away after that conversation and just decided to get on with it and start building it. But I was certainly pleasantly surprised when I found out, and the progress and the leaps and bounds that him and his team have made have been nothing short of astonishing. So, to show you what I personally think is one of the coolest tools in the Bitcoin space, we have the CEO of sCrypt, Xiaohui Liu, to demonstrate for us.
Thanks for the introduction, Steve. And I hope today I bring some more good surprises to you by showing what we have our progress so far. So, hello everyone watching. My name is Xiaohui Liu. I'm the creator of sCrypt. So basically, we are a startup in this BSV space offering integrated smart contract solutions. So let's get started. Today's topic is about developing smart contracts on Bitcoin SV. So when people usually regard Bitcoin or Bitcoin SV, they don't usually regard it as some kind of a platform that you can develop apps or contracts on. You usually think of as just pure money transfer. So today I'm going to show you, besides the money transfer aspect, the other aspect, whether yes, you can actually develop a lot of actually arbitrary contracts on top of this BSV platform. And today, and especially my talk, will be a lot of hands-on to show a lot of demos, and we can even start writing some simple code. I will walk you through some of the first, give a basic sense of what the Ascript, the languages, it looks like, and then I'll walk through the whole workflow to get you from set up the environment until you start writing some code. You can test it, you can debug it, and then finally you can be practical. You can deploy the contracts on chain and call it just like any other contract you have encountered so far. So before I dive into all the details, so first give a high level, what is the contract on top of Bitcoin? So this model is a little bit of a unique because it's based on the so-called UTXO model. So if you look at the transactions, usually Bitcoin transaction consists of inputs and outputs. So think about this way. One example would be when you send a Bitcoin. So you are taking existing UTXOs, you are spending this, and you are giving, so let's say Alice sends 1 Bitcoin to Bob. So what it actually happens is Alice, the so-called, it takes Alex UTXO and then unlock the coins inside the UTXO and put into new UTXOs. And in this new UTXOs, only Bob can unlock. So if you zoom inside each UTXO, as we do in the example here, we have transaction 1, transaction 2. So in the output, the first output of transaction 1, you can think of that's a lock. So who can spend it? Only the person who has the corresponding key that can unlock the lock. You can unlock it. Only in this case, you can spend the coins inside. So that's how the Bitcoin's contract works. So basically, for each UTXO, basically Bitcoins, there's a lock on top of it. There's a lock in it. So the lock is expressed in native script. And then when you unlock it, you plug in the key, which is also a script. So you combine these two together. If you run them, if it returns true, then you can successfully spend the coin. Otherwise, you'll be rejected. As you can see on the right side, there's some examples of some non-trivial script. So you can think of anything that you want to express in this smart contract, you can actually write it in native script. That's in theory. You can do everything in script, but there's one slight problem. It's like assembly language, right? Is as Craig yesterday also talked about when he talked about the origins of script, is more like assembly. It's a low level. So it's when he first even designed it, it's never intended to be used directly. So it's always the case there's some more abstraction like Ascript, which is a high level language. If you look at the left of the screen, so you can get a sense it's more or less look like JavaScript, or some people may heard about Solidity or other kind of modern language. So you can have defined variables, you can define functions. Instead of, you can also have types. So that makes it more friendly to developers. Ascript is, you can think of as a functionally is equivalent to script, but the only thing is built on top of it and builds a wrapper and syntactic sugar on top of it. So you don't have to deal with the assembly level, low level, this esoteric language, which I don't know about you, but I don't usually like programming in assembly. So let's just walk through one example of like a hello world contract. What does it look like? So in this example, I put the so-called contract demo. So it's a contract is similar to class in object-oriented programming languages. So for example, again, also you can define X, Y here as properties, or you can say it's state variables. Of course, you have constructors to initialize these variables. And also you can see that's one example I show here. You can define functions. For example, you can define sum. So basically here, you can intuitively see the language is pretty self-explanatory. So basically you have integer A and B, and then you can sum them by just plus, and then return it as the result. So I think the thing I highlighted here are some of the unique features for Ascript. So you can see some functions, they have this modifier called public. So what does it mean? So the contract, right? Like any other contract, smart contract you have seen other blockchain. So basically the way you use it, you deploy it and then you call it, right? So what public means, so for these functions, not only you can call inside Ascript code, but you can also call it from outside of the Ascript code, which is by sending transactions. So this kind of functions, you put a public in front of it. So in this case, we have a add public function. We also have a sub public function. So inside this, there's a statement called require. So for a lot of other, for developers coming from other platform or in general, this is similar to assertion in a lot of languages like C++ or even JavaScript. So basically this is a statement that this is the function that takes a Boolean expression. So if this expression is true, it will do nothing. You just keep running. So if it's false, it will fail the whole thing immediately. It's like assertion. So how does this contract map to the locking, unlocking we have mentioned previously? So basically for each public function, the body you can think of as they will go to the locking script part of the contract. And whatever you plug in for the arguments is in the unlocking script. So in this case, the easiest way to think of is the int z that will go into the unlocking script. If that is equals to the sum of the x and y you plug in earlier in the locking script, then you will unlock. Otherwise, you will fail. So next, let's get some practical. So in this example, I will show our IDEs. Let's switch to the VS Code. So we have released actually two IDEs. One is the desktop version. So you can see here. So for people who are not familiar with VS Code, so this is one very popular IDE, if not the most. So basically, the biggest advantage is you can have you can support any language by install the its corresponding extensions. For example, here, in this case, once you download install the VS Code, you can go to extension market here. And easiest way to support Ascript is just search Ascript. And then it will lead you to our extension here, which you can see. So after you can click one click, you can install, and then. So now we have seen the Visual Studio code, and I showed you the steps to install our extension. Basically, you search Ascript in the extension market, and then you click install. Then that's all you have to do to get started. Nothing else, just one click, and you are about to enter the world of Ascript. So I previously showed the Hello World demo contract, so you can see it here. As usual, you can see all it's highlighted. You can hover functions. You can show the function signatures, inputs, output, return values, type. You can also hover upon variables. It will show you what is the type. You can also, if you press Control, and then you can also follow. You go to this definition. So for example, here you have X, we can click and you can go back to X. And also you can, as you type, for example, I show some example, if you can start typing, you also give you the auto completion features as well. For example, here you can type I, you can import, you can type if, you can type integer type as well. So it's basically, it looks like any other standard IDE these days. You can get all the language features inside this with this one installation of the SDK. Besides the desktop IDE, we also have the cloud version. Basically, this serves as a different purpose. So this is for people who just want to, they just learn about heard about Ascript. They just want to start play with it immediately without doing anything else. So if you want just to try it out simply, so we have this cloud IDE called the Ascript Studio. So you can click and go. I think let me briefly show it here as well. Show the web browser. So here we can go to Ascript.studio. So this also is almost like a web version of the previous Visual Studio IDE I've showed. So inside here, you can also compile. You can also run it. And you can also, there's also a very nice visual debugger built in. So you can step through code. You can set breakpoints. So for example, if I can go next step, okay, I can also debug. I can run through different, you can see the opcodes, and also you can see how the stacks change. So another thing I want to mention is, so besides Ascript, you can also run native script. So you don't have to write Ascript code here. If you want to debug a native script, you can also type in here, and this gives you a very good tool to debug your native script if you want. So after I show you how you can write some contract and based on some of the basic syntax, so let's get what's the next. Usually in a standard software development workflow is right now you have a contract, right? You are playing with real money here. So you want to be very confident before you actually deploy this on chain. So what do you usually do? You write a lot of tests, right? But if you just use native script, yeah, you can do it. I mean, maybe with some of the tools, I think the Steve Shadders showed one way how you can play with it, but it's not that standard to whatever we developers usually use in our daily life, right? So for that to happen, we also build a testing framework. So in JavaScript, so if you are familiar with JavaScript, there are a lot of testing framework. So the good thing about us is for our testing framework, you can use any underlying framework you like. For example, you can use Jest, you can use Mocha, some people use Chai. And in this example, we just using Mocha as an example. So let me demonstrate how it works in this case. So let's go back to the Visual Studio Code. Okay, again here we have previously we have the demo code. So on the right hand side, I also show. Let me enlarge this so you can see clearer. So, for example, here in this demo.ascript_test.js, we test this JavaScript in JavaScript code. So you can notice this, we have this this SDK tool called the build contract class. So basically you tell which contract it is, and then it will be translated or in some other language called reflected into a native JavaScript class. So once it's reflected into JavaScript class, you can use it as any other JavaScript class. You can use it. You know, this is essentially translate to calling the constructor here. So for example, here new, I give it 7.4, and again, then you can write expectations or assertions on top of this. So in this example, because I'm using try here, so you can see I'm calling the add function, the public function. I can call it. I can give it for example here, right? So I can run it. So here I can just try it on. Let's click run. Oh, this also I installed another Mocha plugin that lets me just run it directly from here. I can show you ways to how you run if you don't have this extension. So of course here you can see because I use 7.4 to initialize this, and add is pretty much doing the sum. So if I give it a sum, it will be true. So what if I give it a wrong number? We expect, right? We expect it to fail. In this case, we can run here. We can quickly run. Okay, now it's good, right? So this basically lets you to write the Bitcoin smart contracts as you write any other like modern languages like a Python or JavaScript or Java. And this very nice little tool we built, you can let you very quickly to test your contracts very easily. So as I mentioned, if there's one way is to install this extension in test runner. Basically, is a test runner. You can run it here. You can see all the tests. You can run them individually or by group. Another way, if you don't install any other extension, the easiest way would also right-click and say run Ascript test. So we are running this demo. Okay, now also you can see this runs all good. All right. So once you have start writing test, what usually happens? You are not, I don't know about you, but when I write test, it usually doesn't work for the first time, right? So for example, what if there's some bug in my demo contract? So if I put a wrong number, let's say if instead of putting 11, you can imagine if I put 10, right? In this case, what do you expect? Expect it to fail, right? Let's run it quickly here. Oh, okay. Now it says fail because 7 plus 4 is not equal to 10. So what we need here is, besides the testing frame, we also need a debugger, right? So let me show you how to run this here. So for this, because I want to use a more complex, more practical contract to show you this, I choose, there's another contract called, we have in our SDK we released called Ackerman. So basically this is more complex than the previous one. So I want to briefly demonstrate how you use this. So again, this is the standard Visual Studio workflow. You go to debug, and then in the dropdown, you can configure which contract you want to debug. And for this to work, you also need, I think this is all standard Visual Studio. This is not specific to Ascript testing. So in VS Code, you can configure your debug using this so-called launch.json file. So basically, the JSON file, you will specify what kind of tests you want to have, what parameters you have. So for example, I'm choosing to using Ackerman contract, and this is the constructor parameters I give it to you. This is the public function, which is called unlock. I want to call, and this is the y value I'm giving. So once we have this configuration ready, we can start the debugging section. So before I start there, I think you can see around here, I also put a few breaking points here, so it doesn't just run immediately and finish. So let's start it. So you can go to Debugger and choose Ackerman, or you can choose any other ones for here. I want to demo this one. So you can just click Run, and then the debugger session will be live in, just give it a few seconds. Okay, now we are up. So you can see, we can go back. Now you can see on this screen, now it looks like any other debugger, right? So you have this control widget over here, which you can do, you can continue to the next breakpoint, okay? So we can set up, let's say, another breakpoint randomly here. We can go to the next one. We can, you can step by step, you can go to, say, the next step, right? On the right hand, you can see all the variables. We have class properties. Let me minimize this so we don't. Oh, you can on the left hand side, you can see all these variable values currently. You can see A, B. We have plugin. You have C local variables M and N, and also you can see some so-called block variables because this is decided within this if block. So you can see the top value here. And also, as usual, you can also set which kind of variable you want to watch. For example, here, I set some, you can set, let's say, this B. You can watch it. I can, for example, I can change it, this B. You can watch, and you can also here see the call stack. For example, this is the entry point. Now we are in this function called Ackerman. So you have unlock, you have Ackerman, and also this show all the breakpoints. This is like any other programming language debugger. It's no surprise. So also another way we can see is to interact with it through the so-called console debug console. So basically this is the repo. If you, like any other repo, you can, instead of compile and deploy and test, you can start playing with it here immediately by typing some expressions. For example, you can type some simple expressions in. This is as if you are writing Ascript code. So you can also start with this. This is the debugger we just mentioned. Let me switch back to slides again. So we showed the testing, and we showed when testing fails, what do? You debug. So we have the debugger session as well. How do you configure it, and how do you write and set breakpoints, watch variables, all this standard debugging techniques. This will help you identify, hopefully catch most of the bugs you can have. So, and eventually, right, when you have debugged, when you're writing a lot of tests, they're all looking good. What do you do next? You want to be real, right? So you want to deploy it on chain and try it. You put a contract, deploy your contract on chain, and then you call its the so-called functions, right, methods. So in order to facilitate that, so in theory, you can put the native script. You can get from the compiler. You can put it manually into the locking script part, and then you can also compose your unlocking script manually. But it's a very standard way. We publish some SDKs to simplify all this, because this is the most basic pattern. So we want to make your life easier. That's the whole point for the Ascript, is to make the developing smart contracts on BSV as easy as if you are writing JavaScript code. So let me go back to the code here as well. Go back. So let me first start the debugger. So coming back, again, let's say using the example of demo. For example, now I'm very confident this works as I expected. So what I do, I want to deploy it, right? So I have here got another file called demo.js. So basically this one will deploy this contract and call a few functions. This will basically put this contract inside one transaction, and then have another transaction spending the previous one by unlocking it. So again, it's only a few lines of code. We can, if you remember our previous test example, we also have the major one called a build contract class. So this basically reflect or convert the Ascript contract into a native JavaScript class. So once you have that, you can easily see this is very similar to the test code. You can have the compiled code. You can put inside this, basically place this contract inside a contract, inside a transaction, sorry, and then broadcast it. And this is the first transaction by deploying the contract. And afterwards, immediately, you can go to the other step. You can unlock it. So basically, this one here, this is your locking script that's get deployed, and the next part is immediately unlock it. So let's try it on the real network and see how it goes. So I'm praying to my demo god. So let's see this. Hopefully this is live. So we'll see. So basically this is all part of the SDK. You can download this. I'll show you later where you can find this easily. So basically the only thing you need is plugging a private key. So for this, because it's demo purpose, I just use a testnet. So you can steal the test coins. That's fine. So the way I try to write, I already have some NPS. I also already write some script to handle this. So we can just run this npm script. So called npm run.testnet. Okay, this seems working now. So basically, it shows succeeded on testnet and give me the transaction IDs for the two transactions. One is deploy the contract. The other one is to call the contract by unlocking it. So let's go to our favorite block explorer and just verify it actually works. So let's go to the browser again, and let's go to Watson chain that I showed here. You can, okay, find, okay, it's here, we found it. You can see this is pretty much, you can go to for looking at our contract, we go to the scripts tab, we can see here. So this is our contract, what it looks like in native script. You can see it's not very human readable. Even it's not a big contract, you can see it's not very easy to understand. And the good thing is we already wrapped up in Ascript. It's very easy. And also we can see it here. So previously we showed, you can get a little bit of numbers here. We showed when you deploy the contract, you initialize X and Y as 4 and 7. So basically in the end, in order to unlock it, you have to put the sum. So which is here is 11. So you can see that's why it gets unlocked. So meaning, okay, we have just successfully deployed our first contract and unlock it as well, all with just one line. We just plug in our private key. That's it. Everything else is done by our framework. So I just showed, I think, the little bit overwhelming lot of information here. So where do you find us? Let's go to the final slide we can show. So we just, what we have done so far. So we have showed our IDEs you can download. Then you can edit, you can develop, write your contract. After you write it, you can write a lot of tests. There's with it, using our testing framework, it's almost like you are writing JavaScript. And then you have showed you how do you do, if something goes wrong during the test, which happens most of the time, and how do you debug and fix it? And then once you feel confident this is working, then how do you deploy it? So all of this you can find us on our website, ascript.io. So there you can find the formal. Let me go to this website, ascript.io, and show what we have there. All the information I just showed is all listed there conveniently. So you can go to ascript.io. Okay, ascript.io. You can find our IDE download links. You can find our web version as well. You can also find the formal specification for the Ascript language, which I can show you briefly here again. Is you can show all the syntax, and I even have some examples. And one last thing I want to point out, you can also go to our GitHub. So by clicking here, this is where you find all of our SDKs. So for example, the most used one is this repo called boilerplate. So basically, the recommended way to start any Ascript project of your own is to git clone this and use this as a standard boilerplate, just like what I have shown in the IDE as well. So lastly, but not least importantly, you can find us on all the social media. You can, I just showed you very like a hello world-ish examples. And actually you can, beside this very basic contracts, you can write any arbitrary contracts you can have actually on Bitcoin SV today. And you can have any other chain contract that you can write on any other chain. You can write it here, and it's much cheaper. I think it's, for example, I showed some token examples previously. So if you look at the transaction fee, it's about 100 or even sometimes 1,000 times cheaper than the transaction fees on other chains. And because we can scale, you never have CryptoKitty and blocking the whole network. You will never have it. And also we also have a lot of examples. For example, you can maintain state, you can do atomic swap, you can do articles, you can do insurance and inheritance. So for all this example, you can find on our medium.com, which we have released a series articles to how to develop non-trivial contracts. You can find here. And again, lastly, if you have any questions, you can go to our Slack channel and ask any questions there. So thank you. I look forward to hearing questions from you guys.
So not surprisingly, I've got a couple of questions of my own, but we'll get through the audience questions first. Firstly, actually hear from Raoul is it's probably more of a question for Bitcoin Association, but it's an important topic. Raoul asks, is there any workshop or course to learn Bitcoin SV programming for normal people, I mean, without prior knowledge? this is certainly something that I expect a lot of people are going to ask over the next few months. So the short answer is there are some resources out right now, including the Bitcoin wiki, which you can find on wiki.bitcoinsv.io, which is a great place to start learning the fundamentals, I guess, of Bitcoin SV, and in particular, a great place to unlearn some of the ideas around BTC, which are actually just not applicable or just plain wrong when you're talking about Bitcoin SV. So that's a good starting point. But the Bitcoin Association has an education program in the works right now. It's well and truly coming along, and they're developing a full curriculum. So later this year, they expect to be releasing the first course materials, or actually courses that you can take. And the goal is for those courses to be available either as delivered in person or online, and other formats as well. And they're meant to target both beginner, intermediate, and advanced. So in the short term, the Bitcoin Wiki is a good place to start, and Slack channels, the various Slack channels and Telegram channels, the sCrypt channel is a great place to find knowledgeable people. So you're not short of places to go to learn right now, but keep your eye out for that later on. So Xiaohui, Will Divine asks, can we make non-fungible tokens with the op push TX method so that each token could have a unique serial number?
Oh yes, that's a very good question. So as I just mentioned, if you go to our official website, and then which links to our medium.com series of articles. So the latest we've released is how do you use op push transaction to issue fungible tokens, right? So with that example, it's not difficult to extend it to non-fungibles. So think about this way, right? So the fungible tokens is for each token type, for each token. For each owner, you can have a certain number of tokens, right? So when you transfer the tokens, you have to make sure the total number of tokens doesn't change before and afterwards, right? They have to equal. Whatever you have before, you have, once you transfer, you still have same number of tokens. So there you're comparing the numerical equality, right? So for fungible, the only thing you have to change is instead of numerical equality, you use set equality, right? So instead of each for example, each publicly how many tokens you have, so it will be a set of tokens. So you have token A, B, and C, right? So after you transfer, you make sure the set of tokens in the output is going to be the same. You still have A, B, C. And so instead of numbers, you have a set. So instead of comparing equality numerically, you check the set equality. I think that you are not the first person asking this. So I may update it or write another article on how to do fungible tokens and give you some code. So very good question, yes.
Okay, so a couple of questions from me. As you know, I'm building a tool that's a long way behind yours in terms of its development progress, but it's also, I guess, quite differently targeted. It's intended for probably a lower level of programming, and I'm interested in how that might be able to integrate with sCrypt or be a useful tool for sCrypt even. But before we get to that, how do you have a model, I guess, in mind for code reuse? Let's say I wanted to build a sort of a functional library for, let's say for argument's sake, ECDSA math, elliptic curve math with functions like point multiplication and things like that that can be expressed in script. How could I go about doing that with sCrypt and then make a library available for other developers to use in their sCrypt projects? Is that something that you support now, or?
Yes. So there are actually two ways. One, you can do it now. The other, I think there's a new feature coming. So So the whole thing we have, why we have the concept of abstraction as a contract is the number one reason is actually so it can be reused. So there's a syntax called import contract, right?
Mm-hmm.
So existing, you have, for example, you have a contract called bar. You have another contract called food.ascript. So in the bar contract, you can simply just import the full contract. Then you can share the code as it's like any other standard language libraries. For example, in your example, right? If you can write your code in Ascript, then you can just share it on GitHub or anywhere, and people just download and say import. So going forward, you can even imagine we have our own package manager. It's almost like an npm, but it's Gradle for Java or Stack for Haskell. You can imagine we have our own package manager just for Ascript. So it's almost like a unique. It's another package manager, so you don't have to go to GitHub or whatever. You can find this contract. You just npm install, say ECDSA. That's one way, right? If you can write in Ascript, you can do it today by import your file, Ascript file. So another way is, I think what you are hinting is you have your native script implementation, right? So you may not, for whatever reason, you're not writing this function in Ascript, either because it's optimized or whatever. So there's another syntax where we're going to write. Basically, this is for low level, because Ascript is high level, right? So, but we also want to people who's like you, they're already master of native script. So we are allowed this syntax called ASM. Is I think some other language like I think C and also Solidity also allows you to embed a native language with this little bit, if you know exactly what you're playing with, you can see we have this statement called ASM, and inside you can write native script. And this will be compiled directly into Ascript code as well. Okay. So yeah, basically you have one way which you can work today by writing in Ascript, but if you only have script, I think that's one thing I need to add this feature. Basically has ASM you can embed.
That sounds like something we should definitely have a talk about offline.
Yes, yes, we can definitely.
I have some ideas there myself in terms of the interoperability.
Okay.
We've probably just got time very quickly for one more question. I'll have to ask you to keep the answer short. Can you explain your thoughts on what Ethereum's Solidity plus gas solution missed in terms of allowing scalable scripting contracts? Is the idea good and the execution wrong, or perhaps the idea is just terrible in the first place?
Yeah, simple answer is wrong. So there are a lot of reasons. I think Steve and Craig covered yesterday why we don't. The whole point for gas is because you can have, you don't know whether your program will ever stop, the halting problem, right? Because for script, we don't have the ability to jump and loop natively. You can do a lot, you can build abstractions on top of it, but natively, you cannot jump back. So we never have this halting problem. If you can compile, it will halt because the script execution is sequential, right? So you take the script, you run from the first byte till the last bytecode or opcode. You can always, there's no jumping back. So you can always sure you will finish because it's finite, it's fitting within a transaction, right? Versus Ethereum or Solidity or bytecode, there's a jumping instruction and looping. You don't know whether it will add. So it's a regress, I would say, to put it that way. We don't need gas. We don't need gas, and it's much simpler, more secure. You always halt.
For sure. Okay. Well, we need to wrap up now because it's only a couple of minutes until our next presentation. So thank you very much, Xiaohui, and looking forward to working with you more in the future. And Anybody who wants an easy road into writing Bitcoin scripts, go check out sCrypt.io. Thank you.
Okay, thank you.